Hi all, let's take a look at section 3.7 on Achieve, dealing with the chain rule. This is the first of the derivative rules that I absolutely love. Achieve doesn't do too many complicated chain rule problems, but they do enough to where that you should be able to get a good grasp of how to use the chain rule if you can do the problems in this section successfully. I would encourage you to also look at my book homework assignment. It's got many more examples, some of which are more involved than what the Achieve assignment can get into. For this first problem, it asks us to take the derivative with respect to x of 2 sine of x to the 10th. So as we know, the chain rule applies to the composition of functions. And what you need to understand in order to do this problem successfully is that the function x to the 10th is composed inside of the sine function. So the chain rule says take the derivative of the outer function first. Well, the derivative of 2 times the sine is 2 cosine. Leave the inside alone. That's why there's still the x to the 10th. And then after you do that, you multiply by the derivative of what was on the inside. So we say, well, the derivative of x to the 10th is 10x to the 9th. This is our final answer. Now, in order to simplify that, all I did is I brought the 10x to the 9th up front, multiplied it by the 2. I thought it looked best to write my answer as 20x to the 9th, the cosine of x to the 10th. And typically, just FYI, as far as common notations, we always put the constants and algebraic terms before any trigonometric term within a term in a function. It's not a written rule, but it's just the way that it's typically done. So you can see that Achieve accepted that final answer, no problem. For the next problem here, it gave me or it asked me to find the derivative using the chain rule of y equals the square root of 16t squared plus 9. Okay, so in order to do that, it's best if you'll first understand that that square root means that we have the group 16t squared plus 9 to the 1/2 power. Now it's clear that my inside function is 16t squared plus 9. My outside function is x to the 1/2 power. Take the derivative of the outside first. 1/2 comes down in front of the group, left alone on the inside. Decrease the power by 1. All of this is the derivative of the outside. Then you have to say times the derivative of the inside. Well, the derivative of what's inside this function is 32t. Now, sometimes students don't understand, where do you stop with a chain rule? So this is a 2-layer chain. Why is it not a 3-layer chain? Well, the only thing that would be inside of this function 32t would be t. And then you say, but the derivative of t with respect to t would just be 1. So even if you tried to do what's the times the derivative of what's inside this function, you're not going to get anything other than a factor of 1. So we can say, okay, final answer. I'll multiply the 32t by the 1/2 and get 16t in the numerator. This group to the negative 1/2 power means that square root of 16t squared plus 9 belongs in the denominator. And again, you can see that Achieve accepted that answer just as I have it written there. Now for my next problem here, a little bit more complicated, but that's okay. It gave me this group to the 2/5 power. Actually, it's not that much more complicated. The answer just makes it look complicated. You'd say, well, it's the same thing as the last problem. You bring the 2/5 down in front, times the group to the 1 lower power to the negative 3/5, and then you multiply by the derivative of the inside. Derivative of x to the 10th is 10x to the 9th, minus the derivative of x cubed, which is 3x squared. Of course, derivative of 0 is 1 is 0, so it doesn't contribute anything. So I have derivative of the outside times the derivative of the inside. What I went ahead and did is I said, well, this derivative of the inside, I could factor an x squared out of that. Now, you don't have to do that, but it's good if you do. And you'll see I factored that x squared, multiplied it by that 2 that I already had in the numerator times the remaining factor of 10x to the 7th minus 3. All of this group belonged in the denominator along with a 5, and when I put that group in the denominator, it's going to go to the positive 3/5 power. Final correct answer. Now, since the original was written in fractional exponents, it's fine for my answer to be in fractional exponents. So good final answer there. Number 4. You can see here on number 4, again, it's asking me to take the derivative of a group to a power. This time the group it's asking me to take the derivative of is a fraction. So I said, well, okay, the derivative with respect to x of the group x plus 4 over x minus 4 to the 5th. Derivative of the outside, 5 times the group to the 1 lower power to the 4th. Now, times the derivative of what's inside the group. Well, quotient rule. You squared the denominator, bring the denominator up to the numerator, times the derivative of the numerator, which is 1, minus the numerator, times the derivative of the denominator, which is yet again 1. So now I need to simplify this expression, and it simplifies easily. What I notice is that I'll have a factor of x minus 4 to the 4th times x minus 4 squared in the denominator. That's where the x minus 4 to the 6th came from. Now, in the numerator, I'm going to have a factor of 5 times the group x plus 4 to the 4th, and then whatever I get from this. And please notice over here, you'll have x minus x cancels, but then you'll have negative 4 minus 4. That's where I got my factor of negative 8. Well, now I simplify and say, well, that negative 8 multiplies the 5, and I'll get negative 40 times the group x plus 4 to the 4th over x minus 4 to the 6th power. Final answer there. Now, for number 5, it gave me a pretty simplistic exponential function. This one's quick and easy. You'll see it didn't take me much work to do it at all. We remember the derivative of any exponential function is that exponential function. But now we have to worry about the chain rule. And you say, well, yeah, okay, the derivative of the exponential part may be just that exponential function, but there's a function inside of that. So the chain rule says you have to multiply by the derivative of the function inside of that exponential function. So the derivative of e to the 2x to the 6th is derivative of the outside. Derivative of any exponential function is that exponential function. But now I have to say times the derivative of what was inside of it. Well, what's inside of it is the function 2x to the 6th. The derivative of 2x to the 6th would be 12x to the 5th. And then I can say, okay, now this is my final derivative answer. Just like with trigonometric functions, typically you bring the constant and the algebraic term out in front of the exponential. It would have been okay to write it this way, but it's better to write it as 12x to the 5th e to the 2x to the 6th power. And you can see that that's the way that Achieve wanted it there. For number 6, we have another exponential function. So 5 and 6, pretty much the same problem. This time it puts the exponent in terms of t, so we know we're taking the derivative with respect to t. So I can say, okay, derivative of any exponential function is that exponential function times the derivative of its exponent. Derivative of 2 is 0, but the derivative of minus 3t to the 6th is going to be negative 18t to the 5th. So exponential function times the derivative of its exponent. And I can say, okay, good answer, but it's better written as negative 18t to the 5th times that exponential function. And you can see that's what I entered here. For number 7, so it's giving me a function within a sine function. So I can say, okay, again, the sine function is the outer function. I know I can say, well, derivative of sine is cosine. Please remember, you always keep the angle. So angles will never change through differentiation or integration. So I can say, well, derivative of the outside, keep the inside, times the derivative of what was inside. Derivative of x to the 10th is 10x to the 9th. Derivative of 18x, 18. Final answer there. I could have put this group out in front of the cosine, but it doesn't really matter in this scenario. It probably would have been a bit better. but you can see I entered it in just like I did on my paper, and Achieve accepted it, no problem. Now for the next one, oh, I like this. I need you to understand the difference in number 7 and number 8. At first glance, a student might think, well, it's the similar type of problem. No, it is not. Number 7, you just had a trig function with a function for its angle. So you had to say, well, chain rule, derivative of the outside times the derivative of the inside. This is more than that. Yes, I have a function as the angle of my cosine function, but I also have that multiplied by a function of x. This is going to require the product rule and then the chain rule within the product rule. So I say, okay, derivative of the first, 1, times the second, plus the first, x, times the derivative of the second. Well, derivative of cosine is negative sine. And remember, if you're showing your work on paper like that, it's absolutely mandatory that you have this negative here, or else just go ahead and change the sign out in front. If you have x and then this negative sign without that parentheses, it's understood to be x minus the sine of that angle, which is terrible. It's x times a negative sine of this angle, 9 minus 13x, and now the chain rule says, oh, you got to multiply by the derivative of that angle being negative 13. So now to simplify, my first term is just the cosine of 9 minus 13x, and then this last term, I'll get a negative 13 times a negative 1 times an x. That's going to give me plus 13x, sine of that angle, 9 minus 13x, which you can see again, that's precisely how I entered it in on Achieve, and Achieve liked it. For my next one here, it's giving me 3 sine of x to the 8th times the cosine of x to the 8th. So it's just like the last problem, this one's going to require the product rule because it's a differentiable function, 3 sine of x to the 8th, times another differentiable function, the cosine of x to the 8th. And both of them have a function as the angle that has a further derivative. So chain rule within both parts of this product rule. So I'll say, okay, derivative of this group is, well, it's the derivative of the first. Derivative of 3 sine is 3 cosine of that angle times the derivative of the angle, 8x to the 7th. So all of this is the derivative of the first times the second, plus the first, 3 sine of x to the 8th, now times the derivative of the second. Well, derivative of cosine is negative sine, and again, that parentheses is not optional if you're showing your work on paper. Absolutely mandatory. So derivative of cosine, negative sine of x to the 8th, and then I have times the derivative of the angle again, 8x to the 7th. Let me go ahead and make this bigger. So now, when I'm simplifying out this first group, I just said, well, 3 times 8x to the 7th, that's going to give me 24x to the 7th times, I had cosine of x to the 8th times cosine of x to the 8th. That's better written as cosine squared x to the 8th. And then I'll have 3 times a negative 1 times an 8x to the 7th. That gives me minus 24x to the 7th. And I would have sine of x to the 8th times sine of x to the 8th, sine squared of x to the 8th. So I get my nice final answer. I could have factored out the 24x to the 7th. I chose not to in this case. And Achieve accepted that answer, no problem. For number 10 here, these are getting increasingly more fun as we go. You can see we have the outer function here is the group to the 1/2 power, 7 times this group to the 1/2 power. So that's going to have to be addressed first. But then when I say times the derivative of the inside, we're going to have to use the product rule and then the quotient rule within, and then the chain rule within each term of that product rule. So this is a pretty cool problem. I'll say, okay, first of all, worry about the derivative of the outer function first. 1/2 comes down, multiplies the 7. I get 7 over 2 times this group to the 1 lower power, negative 1/2 power. Now, times the derivative of the inside. Well, it's that product. No problem. Derivative of the first, derivative of sine is cosine. Keep the angle times the derivative of the angle. You say, well, derivative of 8x is 8. This is derivative of the first times the second, plus, now the first, now I need to say times the derivative of the second. And again, derivative of cosine is negative sine. And then I have the angle 8x times the derivative of that angle, which we get our 8 in that. Now I just need to simplify this gorgeous answer here. So here's what I was thinking. Out of all of this group, clearly I could factor out a factor of 8. So I'm going to have 8 times 7 divided by 2. Well, 8 times 7 is 56. 56 divided by 2 is 28. That's where that came from. And the 2 canceled out of the denominator. Now, I know that this group just is going to become a square root of that group in the denominator. So that's what I did. You could have also just left it to the 1/2 power if you preferred. Now, in the numerator, the 28 constant is going to be multiplying this group. Again, I've already factored out the 8. So what's the first term? Well, cosine of 8x times cosine of 8x, cosine squared of 8x. And then I'll have, instead of a minus, it's going to, plus a negative is minus. So that positive sign changes to a minus, and I'll have sine times sine is sine squared of that angle 8x. Gorgeous final answer right there. And again, if we check that with what Achieve wanted for this problem, it was just fine. And the reason I put that denominator in as a square root, of course, is because the original problem was in radical form. So I would want it on a test. Achieve isn't going to require you to put that back in radical form, though they should. For the next problem here, number 11, we have the derivative of the group, the cosine of 18x plus the sine of x to the 13th, and that entire group raised to the 1/2 power. So similar to the last problem, let me go ahead and look at it with you here. So when I was thinking about this one, again, the first thing that you're supposed to do should be very clear. You always say, well, I need to take the derivative of the outer function first. The outer function is the power on this group. So I can say, okay, derivative of the outside. 1/2 comes down in front of the group times the group left alone to the 1 lower power. Now, that's just the derivative using the power rule on the outside. So now I need to say, well, now I need to multiply by the derivative of what was inside of that group. I do not have a product this time. So I just say, well, I need to take the derivative of the first term. And again, I have to start this off with a parentheses. Otherwise, it will look like I'm trying to subtract a sign. So it's times derivative of cosine is negative sine of the angle 18x times the derivative of the angle 18. All of this is derivative of the first term there. And we say plus the derivative of the sine is cosine. This time my angle is x to the 13th. You need to multiply by the derivative of that angle according to the chain rule. We get our 13x to the 12th. So now all of this, that is a good, correct, beautiful derivative. I just need to get it into a more final format. So what I did is I said, well, this group to the negative 1/2 power belongs as a square root in the denominator. It's going to be multiplied with the 2 in the denominator along with it. And then in the numerator, since I knew that my cosine term was going to be positive and my sine was going to be negative, I went ahead and just said, well, I'm going to call this 13x to the 12th times the cosine of x to the 13th, and then I have minus 18 sine of 18x. That is a gorgeous final format for that answer. For number 12, we'll have a fractional problem, and this one actually takes a step backwards in difficulty. I guess maybe because it went to the quotient rule, they wanted to start with an easy one. But we have the group x plus 1 to the 1/2 power divided by the wimpy linear function x plus 23. So we know that the derivative of any quotient, you just say square the denominator, bring the denominator up to the numerator, times the derivative of the numerator. It's a group to the 1/2 power, which means it's going to be 1/2 times the group to the negative 1/2. And then technically you would say times the derivative of what's on the inside, but that would you'd just be multiplying by 1. So we don't have to worry about that. So this is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which is just 1. So we can say, okay, we have this simplified. I wanted to go ahead. This is a correct derivative. You probably could have entered your answer in that way. I just wanted my answer to look better. So I knew I had a common factor of x plus 1 in my numerator. You always factor out the lower power of it when you take the greatest common factor out. So I'll factor out the x plus 1 to the negative 1/2. I also went ahead and factored out the 1/2. So that removed those two terms from the first term, just leaving x plus 23 when I factored it out of the first term. Now, the second term, minus, well, if you factor a 1/2 out of a 1, it's going to leave you with a factor of 2. And if you factor x plus 1 to the negative 1/2 out of x plus 1 to the 1/2, you're left with x plus 1 to the first for a gorgeously nice solution, because now we can say, ooh, this is going to be pretty. This is going to be pretty. What happens? I know that this 2 could move down as a factor in the denominator. Same thing with this x plus 1 to the 1/2. It can go down to the denominator as x plus 1. It could have went down to the denominator as the square root. I chose to leave it as a fractional exponent since my original problem had fractional exponents. So x plus 1 to the negative 1/2 in the numerator is the same thing as x plus 1 to the 1/2 in the denominator, along with that factor of 2. Now, this came from simplifying this group. I had x minus 2x, that's negative x, and then I would have 23 minus 2 times 1. 23 minus 2 is plus 21. Fully factored final, fantastic format of that answer. Now, you don't have to do all of the algebra steps I did to get to that gorgeous of an answer. It's wonderful if you do, but I bet they would have been satisfied if you put this complicated answer here, because at least then the derivative is still correct. I hope you'll want to simplify to a more useful answer here, though. And the reason this one's more useful, we're going to start wanting to say, well, when does this function have a maximum or minimum value? I can easily look at this and say, well, it has a maximum or minimum value when x is equal to 21, because negative x plus 21 equals 0. I set the fraction equal to 0. That's going to be when it has a horizontal tangent line at any maximum or minimum value. I couldn't see that from this right here. It would be almost impossible, but the simplified version, much more useful. Now, when I go on to 13, I have the derivative with respect to x of the group, tangent to the 5th plus, and be careful here, tangent of x to the 9th. Please understand this is two totally different things. This is the tangent of x to the 1st, that whole function raised to the 5th, and this is just the first power of tangent of an angle to the 9th power. So I can say, okay, need to take the derivative of each one. So the derivative of the first one, I need to think of it as tangent x to the 5th, so the 5 comes down in front, times tangent x to the 4th power, and times the derivative of what's on the inside. I can say, well, the derivative of tangent is secant squared. All of this is the derivative of that first term. Now I move to the second term, and I can say, okay, the outer function this time is the tangent. Derivative of tangent is secant squared. So I get secant squared of that angle, x to the 9th, times the derivative of that angle. Well, derivative of x to the 9th is 9x to the 8th. So then I can say, okay, I have my nice derivative answer here. Is there anything more I can do with it? The only thing I did, typically when you have multiple trig functions, we write them in alphabetical order. So it would be better to write this as 5 secant squared x, and then I went back and put this in the more, you can write it as tangent x to the 4th. It looks more sophisticated to say tangent to the 4th power of x, means the same thing. So I would say 5 secant squared x tangent to the 4th x, and then I brought the algebraic part in front of this one and said plus 9x to the 8th secant squared of x to the 9th. Fully factored final format of the answer. Now, well, actually, there's no factoring there. I shouldn't have said factored, but fully fantastic format of the answer. For 14 here, you have another quotient, and it's not too complicated here. We'll go ahead and take a look at it. Derivative with respect to x of the cosine of the angle 6 plus x over 6 plus cosine x. So as with all quotient rules, we say square the denominator. Bring that denominator to the numerator times the derivative of the numerator. Derivative of cosine is negative sine. Keep the angle. Then you would say times the derivative of the angle, but that's just a 1, so nothing amounts from that. So this is low d high, now minus the high function, the cosine of 6 plus x, times the derivative of the low function, derivative of the denominator. Derivative of 6 is 0. Derivative of the cosine x is negative sine of x. So I know this is my correct derivative. The only thing I did in the next step was to simplify. And I said, well, I've got the group 6 plus cosine x times this negative sine of the angle 6 plus x. So looks like what I did there is all I've done, I kind of left it still multiplied, but I multiplied that factor of -1 out front times I left these two still multiplied there. And then I changed this minus sign or minus a factor of a negative to a plus, and I have the cosine of 6 plus x times the sine of x. And then I really didn't see a nice way to simplify that. Beyond that, I could have distributed and said, well, this is going to be minus 6 sine of 6 plus x, and then minus cosine x sine of 6 plus x, but I really didn't think that that would look any better. So I just left it as that. And just to go ahead and show you, to make sure you see, achieved like that format, no problem. That's exactly how I put it on there. Now for the next question here, number 15, we have the derivative with respect to x of the cotangent of x to the 13th, that whole cotangent function raised to the 15th power. So it's extremely important that you understand this 15 here means this entire group is raised to the 15th power. So we can say, all right, the chain rule says derivative of the outer function first. That's the power. 15 comes down in front, times this cotangent of x to the 13th, all raised now to the one lower power, so it's to the 14th. So that's the derivative of the outside. Then you have to say, well, times the derivative of the inside. What's the next function? Well, there's a cotangent inside of this power. So I have to say times the derivative of the cotangent function. And you can say, well, derivative of cotangent is negative cosecant squared. Yes. So negative cosecant squared, I keep the angle, but then you got to understand you're not done, because you say, well, you kept the angle there because you're supposed to, but that angle has a further derivative. Absolutely. So the chain rule says times the derivative of x to the 13th, which is 13x to the 12th. Now, before you even did this problem, you should have understood that this was a 3-layer chain rule problem. I have a differentiable function inside of a differentiable function inside of a differentiable function. So there's no coincidence that, first thing I did is I said derivative of the power rule on the outside. That's that one. Then I said derivative of the cotangent. That's the negative cosecant squared. Then I said times the derivative of the angle, the 13x to the 12th. So you need to understand this is layer 1, layer 2, layer 3 of that chain. Layer 1, layer 2, layer 3. It's very important that you identify that, especially whenever you have more than just the 2-layer chain rules like a lot of the basic problems are. Now, when I simplified this, all I did is I just said, well, 13 times 15 is going to give me a 195. This is going to make it a negative 195. So negative 195 x to the 12th. And then I'll have cotangent to the 14th of x to the 13th, cosecant squared of x to the 13th. Final answer there. And just again to double check and show you, That's precisely how I entered it in on Achieve and Achieve liked that answer. Okay, guys, I'm going to stop at this and I'll do the remaining problems 16 through 23 in a second video for this section.